Hello students, welcome to the PYQ discussions of chapter 12 linear programming problems, my dears. So we have already discussed the 1 mark questions and the few 5 mark and case based questions that came in 23 and 24. So this video is going to cover the 3 mark questions, my dears. So almost every time you have a 3 mark question and every paper had a different 3 mark question, my dears. In every region, 3 papers, and all 3 papers had a different 3 mark question. So there are a lot of questions to do in 3 marks, my dear. So I have selected few of them, which is different from common methods that we have in LPP. Okay, so let's go to 3 mark questions, my dears. Starting with question number 1, solve graphically the following linear programming problem. They have given you the objective function is to maximize, and they're giving you 3 constraints here, my dears. So the first constraint, equation number 1, is what? 4x plus y greater than or equal to 18. And let us find the intercepts for this line, my dears. So the first intercept is x is equal to 0, y is equal to 80, y is equal to 0, x is equal to 20. So my first intercepts are 0, 80 and 20, 0. First line is ready. Equation number 2, my dears. 3x plus 2y less than or equal to 150. So now let's make the intercepts for this line. X, y, x is equal to 0, y is equal to 75, y is equal to 0, x is equal to 50. The points are 0, 75 and 50, 0. Equation number 2, I told you so many times in the previous video itself why I'm numbering the equations. It's always very easy to draw the diagram and always very easy to find the missing points of intersection. Equation number 3, my dears. X plus 5y greater than or equal to 115. Now let's make the intercepts for that. Yes, x, y, x is equal to 0, y is equal to 115 divided by 5, 5 2s are and 23. Y is equal to 0, x is equal to 115. So we have 3 equations and 3 intercepts. Now let's try to plot. We have very big numbers. See, it's going up to 115 on x and it's going up to 80 on y. So let's mark the coordinates with 20s. So that's easier for us. Let's mark the coordinates with 20s. So let us draw the graph now. I told you it's good if you're able to draw the graph neat and big. And I'm marking it with 20s, 0, 20, 40, 60, 80, 100, 120. Again here 20, 40, 60, 80 is enough on y. Now let's draw the diagram, all of you. The first one 0, 80, 20, 0. 0, 80 would be over here. So the point 0, 80 and the point 20, 0 is going to give me the first line 0, 80, 20, 0, and I'm going to mark it with the name equation number 1. Equation number 1. Okay. Second line, my dears, 0, 75, 50, 0. 0, 75, my dears. 0, 75 is somewhere. This is 70, so somewhere over here, my dears, very close to it. So very carefully you have to draw. That's what I said. 0, 75 and 50, 0. Okay. Now let's draw the line for that. 0, 75 and 50, 0. Okay. 0, 75 and 50, 0 here, my dears. So I'm going to call it as equation number 2. Equation number 3 is 0, 1, 1, 0, 23, my dears. 0, 23 and 115, comma 0. 0, 23 and 115, comma 0. 0, 23 is somewhere over here. 0, 23 and 115 is over here. 115, comma 0. And I'm drawing a line for that as well. Let's call it as equation number 3, my dears. So this is why I said to identify the lines on the graph is not that easy. So you always better draw the graph with numbers for the equation. Now we have to verify which side of the line to shade. Already said in the previous video, every line divides my xy plane into 2 half planes. So we commonly use origin because in most of the cases, origin would be on one side of the half plane. Look at equation number 1. Origin is on one side and the other side. And equation number 2, origin on one side, other side. Equation number 3, origin on one side, the other side. So we check if origin is part of the region that we need for each of the lines. So all of you, let's go for the equations now. Try to put origin here. 0, 0 greater than 80. Equation number 1 says 0, 0. If I put on equation number 1, you will get 0 greater than 80. That means it is false. Equation number 1 says that 0, 0 is not part of its region. Equation number 2, let's try. If I try to put 0, 0 on equation number 2, 3, 0, 2, 0, 0, 0 is less than 150. That is a true case. Okay? Equation number 3, if I put 0, 0. 0, 0 is greater than 115. That's again false. So only for equation number 2, that it's a true region for 0, 0. But for other 2 equations, it's false. So let's go to the equation over here. First line says 0, 0 is a false region. So we need only the region towards the right of the first line. So see this shading that I'm showing now, it's not a very, very important shading that is needed in the graph. I'm just trying to identify the feasible region. Equation number 2, the green one says that origin is a true region. So we have to shade towards the origin for equation number 2. Now the white line says origin is not in its region, so we have to shade away from that line. Because I'm doing the first question in this video, I'm doing it very slowly. Next week question onwards, you will be able to identify it quickly. Now there is only one region where all the 3 shadings that you did coincide, and that is very clearly, my dears, it's very clearly the region over here, my dears. Look at this. This is the region where all the shadings have coincided. This is the region where all the shadings have coincided, my dears. Look at it. There is no doubt about it. This is the region where all the shadings have coincided. Now that's your feasible region, my dears. Okay, that's your feasible region. This is the only region you need to show properly in your exam. I've seen many students making a lot of mistakes in this feasible region part. So please, you have to be very careful with the shading. This is the only region that we need, and we will mark the region's corner points, my dears. Corner point number 1, A, corner point number 2, B, and corner point number 3, C. We don't know any of these corner points, so we are supposed to find all the 3 corner points, my dears. And corner point number 1 can be obtained. A is the intersection of 1, the yellow line, and 3, the white line. So 1 and 3 gives you point A. 1 and 3, 4x plus y equal to 80. 4x plus y equal to 80. and that equation is going to be multiplied with the 2, no need. That equation you can just leave, you can multiply with the 5, my dears. So that will give you 20x plus 5y equals 400. Next equation 3, x plus 5y equals 115. If you subtract it, you will get 19x is equal to 5, 9 minus 1, 8, 3 minus 1, 2, 285. So x is equal to 285 divided by 19. X is equal to 285 divided by 19. So we have to see if it goes or not. So it's going to be 19 ones are 19, and that's going to be 85. 19 fives are. Doesn't go, I think so. Yes, 19 and 285 doesn't go. You have to just leave it like that. And we have to go for y now. All of you, y is equal to 80 minus 4x. Y is equal to 80 minus 4 into 285 by 19. So y is equal to 9 8s are 72, 7, 8 1s are 8 plus 7, 15, 1520 minus 4 5s are 20, 0, 2, 32, 34, 3, 4 2s are 8 plus 3, 11 by 19. So y is equal to 0, 12 and 4 is 8, 4 and 1 is 3, so 318, 80 by 19. So that's going accurately, my dears. Y is equal to 20. Y is equal to 20. So 285, does it go? Yes. 285, 19. 19 ones are 19. So it's going to be 85. So 19 fives are 45, 4. It's 95 goes. Yes. 15 times. That's going. So 15 and 20. So the first point A is 15, 20. So I got the point A. Now we'll go for the point B. Point B is made by equations 2 and 3. Equations 2 and 3. 3x plus 2y equals 150. So I'll take 3, I'll multiply it with 3 over here. Equation number 3, I'll multiply with 3, my dears. So 3 into equation number 3 is x plus 5y equals 115. That is 3x plus 15y is equal to 25 to 5, 355. 15, 5, 1, 3, 1, so 345, I'm sorry. 345. Okay, and next, my dears, I'm trying to find B with equation 3 and equation number 2. 2 is 3x plus 2y equals 150. If you subtract it, you will get 13y is equal to 5, and that's 9, so 195. So y is equal to 13 ones are, so 65, so 13 fives are, so it's 15. Y is equal to 15. Therefore, x is equal to 115 minus 5y. X is equal to 115 minus 15 fives are 75. X is equal to 0, and then 11 and 5 is 40. Therefore, if I solve it, I get equation B as 40, 15. And I got equation A as point A as 15, 20. Now I have to find out point C. Point C is the intersection of 1 and 2. So 1 and 2. So I'll take equation number 1, I'll multiply it with the 2. Equation number 1, I'll multiply with the 2. I will get the equation as 8x plus 2y is equal to 160. 8x plus 2y is equal to 160. Equation number 2, 3x plus 2y is equal to 150. 3x plus 2y is equal to 150. If you subtract it, you will get 5x is equal to 10, x is equal to 2. So again, one more equation we need. To get the value of y is equal to 80 minus 4x. Y is equal to 80 minus 4x. So y is equal to 80 minus 8. Y is equal to 72. So I got the next point C as 2 comma 72. So I got all the three corner points, my dears. So I had to put the points over here. You can see the calculation is quite difficult in this question, though it's for 3 marks. The first point is 1520. The first point is 1520. The second point is 4015. And the third point is 2 comma 72, and that should be substituted in our objective function. Objective function is 6x plus 3y. I want the maximum value 6x plus 3y. So this is going to be 15 6 are 90 plus 20 3s are 60. Answer is 150. Next one, 6 4s are 24, so 240. 15 3s are 45. Answer 285. Next, 6 2s are 12. 72 into 3, that is 6. 7 3s are 216. So 216 plus 12, 228. So we have our values. Therefore, maximum z is equal to 285 at x is equal to 40, y is equal to 15. That is your final answer. My dears, the difficulty that you will face in the exam is about finding the correct feasible region. And here in this question, why it became so lengthy and difficult is you don't know any of the corner points of the feasible region. You had to find all of them by solving the equations. Do not make a calculation mistake. That is the only problem you will have in this kind of questions. Okay? All of you, I think it's clear. Now I can move on with the next question. From next question onwards, I can move more quickly. Now listen here, my dears. I want the maximum value of z or p, which is 100x plus 5y. I have the three equations, starting with equation number 1 again, x plus y less than or equal to 300. Going for the intercepts, my dears. Okay, if x is equal to 0, y is equal to 300. Y is equal to 0, x is equal to 300. So I have my intercepts at 0, 300 and 300, 0. First equation. Next equation, my dears, equation number 2 implies 3x plus y less than or equal to 600. Now if I go for the intercepts for this equation, you have x equal to 0, y is equal to 600. Y is equal to 0, x is equal to 200. So my intercepts are 0, 600, comma 200, comma 0. Equation number 3, my dears. Equation number 3 is y less than or equal to x plus 200. Okay. Now, in this intercepts are going to be what? X, y, x is equal to 0, y is equal to 200. Y is equal to 0, x is equal to minus 200. So my intercepts are, my dears, don't worry about having negative intercepts. Okay, that is not our issue. Our feasible region, this is a non-negative constraint which tells me that the feasible region should stay in the first quadrant. That's all. Drawing the lines, you can do whatever you want, but the feasible region must stay in the first quadrant. Okay, now we're going to draw the graph based on this, my dears. Now all of you please consider the graph. First line I've drawn. So you can see that x goes to negative 200. So I'll make the negative side of x a bit like this. Okay, fine. Now I will mark the points. All of you look at this. I am marking the points with 100. 100, 200, 300, 400, 500, 600, minus 100, minus 200. So my my y has gone up to 600, x has gone only up to 300. It's fine, no problem. My y has gone up to 100, 200, 300, 400, 500, 600. So the first point is 0, 300 to 300, 0. 0, 300 to 300, 0. Zero, 300 to 300, 0. Second line, my dears, 0, 600 to 200, 0. 0, 600 to 200, 0. Equation number 2. Equation number 3, my dears, coming from 0, 200 to minus 200, 0. 0, 200. This is 0, 200. To minus 200, 0. Equation number 3. Now it is just about shading the feasible region. Let us check for the first one. 0, 0 less than 300, origin makes a true statement. 0, 0 less than 600 makes a true statement. 0 less than 200 again makes a true statement. For all the three cases, origin is true, my dears. Okay, it's not necessary you have to show that testing. It's just a rough work. Okay, 0, 0 true, 0, 0 true, 0, 0 true. These are all equations where 0, 0 is one part of the feasible region. So when we go for it, equation number 3 says that 0, 0 is a true region. So you will be shading towards the origin. Okay. Second one, my dears, shade towards the origin. Every line is shading towards the origin. Now, do you see that there is only one region on this graph where all the three shadings are coinciding? That is beautifully this region, my dears. Just look at it. It is this region, all of you. Please check it out. I'm showing the region properly here. All of you, please check it out. This is the feasible region I'm talking about here, my dears. Only shade that region, all of you. Only shade that feasible region properly for your exam. In the exam, only this region is to be shown very neatly. Other regions need not be shaded, my dears. Okay? And this region is made by how many corner points? 1, 2, 3, 4, 5 corner points, my dears. And very carefully, I know this corner point. I know this corner point. I don't know B. I don't know C. I do know D. I do not know B and C. B is made by 1 and 2. 1 and 2 means x plus y and 3x plus y. I will find B, all of you, to find B. And first equation is 3x plus y equals 600. Second equation is x plus y equals 300. If you solve this very clearly, 2x is equal to 300, x is equal to 150, y is also 150, my dears. So I got my point B, which is 150, 150. Now I have to find C made by 1 and 3. 1, 3. 1 says x plus y equals 300. Okay? 1 says x plus y. To find C, 1 says x plus y equals 300. And 3 says y minus x or minus x plus y is equal to 200. Minus x plus y is equal to 200. If you solve it, you will get 2y equals 500. Y is equal to 250. If y is equal to 250, x is equal to 50. Therefore, my point C is 50, 250. Now I have to put this on a table. I know the 5 corner points now. I'll put this on a table, my dears. So my table will consist of 5 corner points. First one, origin 0, 0. The second one is A, which is 200, 0. A, which is 200, 0. Now we have B, which is 150, 150. B, which is 150, 150. C, which is 50 to 50. 50, comma, 250. And D, my dears, is 0, comma, 200. 0, comma, 200. So the question becomes difficult when the number of constraints increases, the number of corner points increases. So from this, what is our Z value? Z value is, its P value 100x plus 5y. P value, my dears, P is equal to 100x plus 5y. The first value of P is 0. The first value of P is 0. Second value of P, 200 and 100 is 20,000. Third value corresponding to B, it is going to be P is equal to 150 with double 0. 150 with double 0. 150 into 5, 15 5s are 75 with a 0. Okay, so 750. So answer is 15,750. Now next one, 50 into 100. It is 5,000. And 250 and 5 is 125. So 1250, it is going to become 6,250. Okay, next one, like my dear, P is equal to 200 into 5. 5 2s are 10, it is 1,000. So you can see I want the maximum value of this, and the maximum value occurs at P is equal to 20,000. Therefore, maximum P is equal to 20,000 at X is equal to 200, Y is equal to 0. So this is the question, my dears. So I hope everybody understood this. So once again, I'm repeating it. Very carefully listen. The difficulty only comes when the number of constraints are more, the number of corner points are more. And it becomes more difficult if you have to find some missing corner points like this. Okay? So I hope everybody understood this question. Next question, my dears. Read it. Minimize Z. Minimize Z. And please, I want everybody to be careful with this particular constraint. Okay, why? Because, my dears, listen very carefully. This constraint is a little bit dangerous for many of you because this constraint does not have a constant. Does not have a constant. A common mistake that happens to many of you. A constraint which does not have a constant is always a line that passes through origin. A line that passes through origin. Okay, so you have to be careful with this line, my dears. We have seen this kind of questions in applications of integrals chapter also. Line passing through origin. Okay, so my dears, equation number 1 is x plus 2y less than or equal to 120. And we will now check our intercepts, the points on the axis. If x is equal to 0, y is equal to 60. Y is equal to 0, x is equal to 120. So my intercepts are 0, 60, 120, 0, the first equation. Equation number 2, my dears, it says that x plus y greater than or equal to 60. And you will try to find the intercepts here, my dears. X is 0, y is 60. Y is 0, x is 60. So my intercepts are 0, 60, 60, 0. Now we are going for the third equation. Equation number 3, my dears. Equation number 3 is very dangerous. Careful. X minus 2y greater than or equal to 0. And this is a line that passes through origin. So you cannot get two intercepts because origin is a point on the line. X is 0, y is also 0. So you can use some other point or some other value you got here already. So I'm using x is equal to 120. X is equal to 120, y is equal to 60. Just to mark the line, that's all. Okay? I'm using just one of the values that we already had here so that it doesn't have a different value corresponding to the figure here. Okay, so use some here. X is equal to 120 is already being used. So use that to get what is the value of y. So that you will get a point very not difficult or not far away from what you already got. Okay, so we got the three equations. We got the required points to draw the diagram. Let us draw the diagram now, my dears. All of you. Diagram. Again, careful, I told you. When you're drawing the diagram, make sure that you don't mark the points like very small when the values are so huge. So your value of x is 120. So I'll stay with 20s now. 20, 40, 60, 80, 100, 100, and I'm going to extend a bit further and I'll mark 120. Okay. The value y goes maximum up to 60 only, so no problem. So it's going to be 20, 40, 60. My dears, first line 0, 60, 120, 0. 0, 60, 120, 0. 0, 60 is over here. 0, 60. 120, 0 is over here. So I got the coordinates for the first line. I'm drawing it and I'm calling it as equation number 1. Equation number 2, my dears, 0, 60, 60, 0. So let's mark it with the 0, 60, the same point over here, and 60, 0, the second point. 60, 0. I'm using the same color to draw the second line. So second line comes over here, and I'm calling it as equation number 2. Now equation number 3 is made by 0, 0 and 120, 60. 0, 0 is over here. Okay. 120 and 60 comes over here, my dears. This is just a point so that I can draw the line without a mistake. Okay. Otherwise, I might get a wrong region. That is why. Only reason I'm marking the second point is I'm getting the direction of the line correct. Now I'm going to check the shaded region. Now again, the difficulty comes not in drawing this line, my dears. The difficulty comes if the line passes through origin, everybody can draw it, but the difficulty comes to the shading. Normally we use origin to test it. My dears, normally we use origin to test the condition. So, but for the equation number 3, I will test not with origin, but something else. I told you the shaded region is obtained by putting any value in its half plane. Do you see 3 makes it into 2 half planes like this? Now in this half plane, you can take any point in the half plane. Like for example, you can take on this half plane 0, 60 or in this half plane 60, 0. That is your choice. Normally origin is on one half plane. So you can use origin because 0, 0 is easy to test. That is why. Here we can't use 0, 0, my dears. We have to use for 60, 0. What would happen to this? 60 minus 0 greater than 0. True. 60, 0 lies on this part of the line, my dears. So for this line, this side is the true region because 60, 0 is a true point of this region. So that's how you decide. You should be careful, my dears. Normally for a line, the feasible region is obtained by using the testing point as 0, 0. But here, when the line passes through origin, you have to use something which is not 0, 0. Got it? So here I chose the point 60, 0 because very clearly 60, 0 is one part of the half plane. Clear? And then the others, we can just simply check with 0, 0 itself. My dear, 0, 0 less than 120, true. Here, 0, 0 greater than 60, false. So for equation number 1, origin is true, but equation number 2, origin is false. Okay? Equation number 1 is the white line which says origin is true. So I have to shade this side of the white line towards the origin. And equation number 2, the green line says origin is false. So I have to shade the other side of the green line. Now do you see that? Very clearly, there is only one region where the yellow, white and the green line are coinciding, and that is very clearly over here, my dears. Yes, all of you, do you see this? This is where the green line is coinciding. Now, all the three shadings are coinciding. Yes, so this is my feasible region, and my feasible region is now going to be marked very clearly on the diagram. So please, my dears, you should be very careful in the exam also. You have to be only showing properly the feasible region. If it is not visible, then you might lose marks. The clarity in the diagram is always for the feasible region, my dears. So now how many corner points do we have here? All of you. We have 4 corner points. Again, 2 points missing. A is given to us, B is given to us, C don't know, D don't know. But C is made by 1 and 3. C is made by 1 and 3. So we are going to find C now, all of you. All of you to find C. To find C, I'm going to use equations 1 and 3. What is equation 1 and 3? X plus 2y and x plus y. No, x plus 2y and x minus 2y. X plus 2y equals 120. X minus 2y equals 0. Correct? 1 and 3, my dears. Yes, solve it, you get what? 2x is equal to 120. X is equal to 60. So y is equal to, if x is equal to 60, you can substitute y is equal to 30. So C is 60 comma 30. Now I'm going to find D, my dears. I'm going to find D. Check the diagram. D is made by equations 3 and 2. 3 and 2. 2 is x plus y and 3 is x minus 2y. X plus y and x minus 2y is equal to 0. X plus y is equal to 60. Yes? Now you subtract it, you will get minus 3y equals minus 60, y is equal to 20. If y is equal to 20, x is equal to 40. Y is equal to 20, x is equal to 40. Therefore, my point D is 40 comma 20. Now I will put this on the equation. My corner points, my dears, I will put it in my corner points. Corner point number A, all of you from the diagram, corner point A is 60, 0. 60, 0. Corner point B is 120, 0. Corner point C is 60, 30. And corner point D is 40, 20. And then we will find the value of Z, which is equal to 5x plus 10y. 5x plus 10y. And we will substitute the points. Yes, 60 and 5 will make Z as 300. 120 and 5 will make Z as 600. 60 and 30 will make Z as 65. Is 300 plus 300, which is equal to again 600. And we will have 40 and 20. Z is equal to 40 makes it 4 5s are 20, 200, and 10 again makes it 200. That is equal to 400. Yes, so I want the minimum value of Z. So it's very easy now. Minimum value of Z is obtained at 300, my dears. They are correct. Minimum Z is equal to 300 at x is equal to 60, y is equal to 0. But do you see the maximum value is having 2 values here? What if they had asked you the maximum value? In the previous video, in the 5-mark questions, I have clearly told you that if an optimal solution is obtained at 2 points, then you will say that here the maximum value is 600 and it is obtained at all the points, all the infinite points that is containing the 2 points B and C. All the infinite points on the line, containing the 2 points B and C. But here they ask us minimum value, and if the question could have been maximum, then definitely you would have done that way. I hope everybody is clear. Yes, next question, my dears. Okay, now look at this. This is again a question based on a constraint which has how many points, my dears? See, this is a constraint without a constant. Constraint without a constant. So you have to be careful with that. Equation number 1, my dears. Equation number 1 says x plus 2y greater than or equal to 100. Now let us try to find the intercepts. X is equal to 0, y is equal to 50. Y is equal to 0, x is equal to 100. So my corner points are 0, 50, 100, 0. Equation number 2 implies 2x minus y less than or equal to 0. Now we will draw the constraints again and draw the intercepts. X is equal to 0, y is equal to 0. So use any point that we already have. Let's use x is equal to 50, y is equal to 100. So my corner points are 0, 0, 50, 100. So please use point which is already existing in the question. Otherwise, you will get some random point which may not suit our diagram. That is why. Equation number 3, my dears. 2x plus y less than or equal to 200. Now use the points again. X is equal to 0, y is equal to 200, y is equal to 0, x is equal to 100. So my points are 0, 200, 100, 0. Yes. Now we'll draw the diagram for this. Again, 3 equations are there. So let us draw the diagram, all of you. Try to understand the graph, all of you. Okay. The graph says the biggest value of x is 100 and the biggest value of y is 200. So to make it more easy and better, so I'm going to mark it in 50s, my dears. I'm going to mark it in 50s. 50, 100, 150, 200. So it's not about the points. It's how good you can draw the diagram. So be smart enough to mark the points on the axis. You mark it with small 10, 20 and it will be very huge. Unnecessary diagram. Okay. Here 0, 50, 100, 0. 0, 50, 100, 0, my dears. 0, 50 over here. And 100, 0 over here. And I will draw a line for that and call it as equation number 1. Equation number 1. Second equation is made by 0, 0, 50, 100. 0, 0 is the origin. 50, 100 is somewhere over here. This is just to get our equation right, my dears. Nothing else. Get the equation right and mark it as equation number 2. Equation number 3, my dear, 0 to 100, 100, 0. 0 to 100, 100, 0. 0 to 100 is over here. 100, 0 is over here. Yes, so the third line is like this. Okay, so I am marking that point equation also. Okay, 0, 200, 100, 0. Now let us check the origin. There is one line passing through origin. Yes, so we cannot use origin to test that. For this, origin is false. Equation number 1 says origin is false. Equation number 3 says origin is true. Now for the first line, you have to shade away from the origin. For the third line, you have to shade towards the origin. But for the second line, my dears, that is line number 2, 100, 0 is one half plane. Yes, so I will test this with 100, 0. All of you, for this I will test with 100, 0. So what is the answer I'll get if I test with 100, 0? So 2 into 100 is 200 minus 0 is less than 0. It's false. My dears, 100, 0. 100, 0 is on this side of the line. Check that 100, 0. So this side is false. I have to shade that side. So all of you come on once again. False for the first line. Means the first line says shade away from the origin. Yes, shade away from the origin. Second line says shade towards the origin. No, sorry, third line. Third line says shade towards the origin. Now, the green line says 100, 0 is false. 100, 0, which is on this side of the line, is false. So you have to shade this side now. My dears, those who are not clear about the shading, please repeatedly go back and watch the video and try to understand how I'm doing the shading, which point I'm using to test. So your only danger comes when the line does not have a constant or which passes through origin. In that case, you cannot use origin to test. You have to use something which is on the other side of the origin, like 100, 0, or this side 0, 100. Now, very clear here, my dears. The line has, or the conditions have brought a feasible region for me now. Yes, and I'm going to mark that feasible region, ladies. This is my feasible region, and the feasible region is made up of, my dears, the feasible region is made up of 1, 2, 3, 4 corner points again. In that, I know only 2 of them. I know A, 0, 50. B, I don't know. C, I don't know. I know D, 0, 200. So I have to find B and C. I have to find B and C. So I'm going to find B. All of you, B is the intersection of 1 and 2. B is the intersection of 1 and 2. Look at equations 1 and 2. 1x plus 2y. 2x minus y. So I'm going to multiply equation number 2 into 1. Okay? 2 is multiplied with equation 1 over here. So 2x plus 4y. 2x plus 4y is equal to 200. 2x plus 4y is equal to 200. And equation number 2, take it the same way. 2x minus y equal to 0. Now if you subtract it, you will get 5y is equal to 200. Y is equal to 40 implies x is equal to, y is equal to 40, x is equal to 20. That implies B is 20, 40. I got the point B, 20, 40. Now I have to use which all equations to find C? C is obtained by 2 and 3. 2 and 3, my dears. 2x minus y, 2x plus y. So 2x minus y. I'm going to find C. All of you to find C. 2x minus y is equal to 0. 2x minus y is equal to 0. 2x plus y is equal to 200. Now this is going to make it 4x is equal to 200. X is equal to 50. X is equal to 50. If x is equal to 50, that implies y is equal to 100. That implies point C is equal to 50, 100. Point C is equal to 50, C. Most of the times you can draw it from the graph itself, but I do not advise that. Always show the point of intersection. Now we'll make a table. My table is made by how many points? The table is made by 4 points. Point A is 0, 50. And point B is 20, 40. Point C is 50, 100. And point D is over there 0, 200. Now we'll put this in the objective function Z. Objective function Z is maximum of x plus 2y. Maximum of x plus 2y. So this is going to become 100. So this is going to be 20 plus 80, again 100. And this becomes 50 plus 200, 250. This becomes 400. So the maximum value is equal to, so the maximum of Z is equal to 400 at x is equal to 0, y is equal to 200. I hope everybody is getting this very clear. Yes. So with this question, I'm going to wind up this video session of 3-mark questions. So I hope everybody understood the idea. So 2 important things I want you to remember, my dears. 2 important things about is a line which passes through origin. Okay, and also in the previous video, I had also shown you what would happen if you get your optimal solutions at 2 points, and also how to handle unbounded solutions. Please watch those 5-mark questions to get the idea on those 2 type of questions. So now the 3-mark questions just purely based on normal questions with difficult values, more number of corner points, that's all. And feasible region for lines which passes through origin, my dears. So I hope this video is very clear. So I'll come back again with another chapter, my dears. Till then, that's it, and bye. Thank you.